Sweet. Okay. So we are recording this meeting like we normally do, so just be aware of that. If you're not speaking and you're on the phone or online, please make sure you have your microphone muted to avoid any background noise while others are talking. And then there is a public comment section on the agenda today for people who are not members of the CAFO committee. And with that, unless there's other housekeeping things that I forget, let's go ahead and go around and do introductions. And we can start with the folks in the room and then we'll go to the folks in the line. So afternoon, everyone. I'm Isaac Stapleton. I'm the Natural Resources Area Program Director, filling in temporarily as the CAFO Program Manager also. So, Katie.
Hi, I'm Katie Carney. I'm with the CAFO Program as a Water Quality Specialist.
Hi, I'm Frank Chaplin. I'm faculty at Oregon State University, here to give a presentation today.
Hello, everyone. I'm Taylor West. I am with DEQ's Water Quality Division as their new CAFO Program Specialist.
I'm Christy Caldwell, and I am with the CAFO program. I'm the program analyst.
Hello, everyone.
My gosh.
No, you don't have to. You're already mic'd up.
Oh, sorry about that, everyone. My name is Mackenzie Landry. I am the CAFO with the CAFO program. I am the administrative specialist.
Your audio too. You just want to go down the list of folks online.
Yeah, so starting off, I'm just going to go down the list here. We will start off with Tammy, please.
I'm Tammy Stark, and I'm just a public member of the committee.
Tammy Kerr, Oregon Dairy Farmers. Good afternoon.
And Tammy Denny, Oregon Cattlemen's Association. Good afternoon.
Sorry about that. Did not see the three Tammys there. But thank you all for being so organized about that. Next, we're going to start with Tom.
Oh, Tom Thompson, Northwest Ag Consulting.
And then we will go with David.
David May. I'm with Valley Fresh Foods Incorporated, Skyline Farms.
Thank you so much. And then Mike.
Mike Freeze. I have several ag clients. Thank you.
Yep, thank you. Ben.
Ben from CAFO Inspector.
Thank you so much. We have Billy.
Billy's muted, so maybe they're away from their computer.
All right, maybe we can come back to Billy, and then I see Amy.
Hey, good afternoon. Amy Rohner. I actually am the new state engineer for NRCS, replacing Molly Dawson, and she forwarded this invite to me. So total newbie, trying to see what's up and how we dovetail into this. So I'll be a fly on the wall.
Thanks for joining us.
And then was there anybody that I missed? No? Okay, we'll move along.
Great. So next, is there any comments or input on the minutes from the last meeting from April 11th? Awkward silence, love it. Okay, so we'll log those minutes and it's approved. The next thing on the agenda today was to talk about some program area updates. There's a few things listed there on the agenda. I'm going to talk first briefly about the manager recruitment, since I'm filling two roles. That's important to me. I just wanted to note that it is out for open recruitment right now. The position closes on the 21st, so that's this coming Sunday. Encourage your friends, families, loved ones to apply. Really, as I'm approaching this recruitment, it's a bit of a unicorn position, I think, in finding someone that has the background knowledge and skills that pertain to CAFO program. I tried to broaden out the interest by not calling it the CAFO program manager and calling it a water quality compliance manager position, because that's really what we're talking about is water quality compliance, to see if I could attract more candidates. So if you're wondering why the title changed, that's what I was trying to do, get a bigger audience. I think the way I look at this recruitment, I'm committed to making sure that we have the right person in the position and not just hiring as quickly as we can because we need a body. So if this takes a little longer, that's part of the reason why we extended the recruitment from its original close date. So that's in the works. Super excited to keep that process moving. We're planning on doing 2 rounds of interviews right now. So we'll start it off with like an internal agency staff and partner agency interview panel, screen out those folks, and then the remaining candidates, whatever kind of rises to the top, we'd do like an industry panel. And I know I've talked to some of you already about participating in that, and kind of depending on schedules and how that all shakes out, we'll see who actually lands on that panel. Just knowing that it's hard to get that many people together for a chunk of time to interview folks. So appreciate those who are able to do that. Any questions on the recruitment? Thoughts, concerns? Anybody you know? Silence is not golden on this topic. The other things I was going to update, we've got several things that are out for public notice right now, and just wanted to talk through each of those briefly. So Senate Bill 85 rules, we started that this last spring, have the Rules Advisory Committee that went through those rules. They've been out for public comments. They will close. We had a hearing on the 15th. Had fairly good attendance, not a lot of comments at the hearing, but good attendance at the hearing. And then the public comment will actually close on the 22nd, so next Monday. And then once that closes, we'll look at all the comments that we received, both in the hearing and then written submissions, and evaluate if changes need to be made or not, and then file those rules permanently. So we should see that, happen, mid to late August or something as we work ourselves through that process. Any questions on Senate Bill 85 and the rules there? Cool. We've also put out a notice for remedial actions for the Fall Line Capital property. Some of you may remember it as the Lost Valley or the Easterday property. That facility has been fully decommissioned. The permit has been canceled, and the current owners are working to address the ongoing groundwater contamination and 3 monitoring wells. And the remedial actions are those that the state would then issue them in order to require them to continue to do it in perpetuity until those background levels fall below what was set at the time the CAFO was brought or built there. So an important thing, I think for us as an agency is that there's no regulatory gaps in that process. So the CAFO permit may be gone, but we still have control and continued oversight as the cleanup continues. So that's really good. Those conditions will run with the land until cleanup is done. So it's not something that the agency will have to go back and keep relitigating with any new owner if it ever changes hands or that kind of thing. So that is out for public comment, and that public comment ends Friday. So tomorrow will be the last day to receive public comment on those remedial actions that we proposed. Any questions on that one? No. Those were the biggies. The last one we have Brownsville Ranch, their nutrient management plan is out for public comment. They made some modifications to that, required it to go to public notice. That it's pretty minor. It's adding 25 acres to their land application area. I'd also note that this isn't necessarily part of why it was noticed, but they've shifted their animal herd from a milking herd to mostly a heifer operation. So little bit different components and they added some land. And so that's out for public comment. And I don't know, Christy, I didn't see where it said the last day to receive comment on that was.
It is the July 29th, and there's a hearing on the 24th at 3
Yeah.
o'clock.
So if you're interested in that hearing, that'll be on the 24th. I think that's the majority of my updates. Are there any questions about the program in general, things that are people have burning that they want to talk about the CAFO program in general about? You guys making this way too easy. I mean, are we muted? Like, what's going on? Okay, great. Well, then I guess I will introduce Frank Chaplin, who did a research project we funded through CAFO dollars. And so, yeah, I think I'll just hand it over to you to introduce the project and yourself and kind of walk us through it.
Sure. How does this, do I stand up at the front?
Yeah, I'm making the
Well,
PowerPoint.
the camera's here, so if you're over here, they can see you. And Kinsey can flip through the slides for you if you'd like that, or however you want to do it.
So I'm a little overslided because I made a mistake about the amount of time. So I'm going to need to click through some slides a little bit quicker just to make sure I keep to the 30 minutes.
Well, I will say we probably have extra time. I mean, if you go over, you're okay.
All right.
We'll let you know if you're getting too far.
I'm just going to sit up here because I have my eyesight.
There you go. Can everyone online see that?
I'm trying to stand.
Yes,
So you,
Tammy's giving us the nod, so we're good. Yeah, you can see. The camera's got you, so you're good.
okay. So
And let me know when you'd like to move forward.
sounds good. So I'm Frank Chaplin. I'm a professor in the Department of Biological and Ecological Engineering at Oregon State University. Historically, we were the Department of Agricultural Engineering, so it seems very pertinent and for us to be doing projects in this area. I've been there for 26 years. I got involved in projects around the wood chip bioreactor with Troy Downing about 10 years ago. We've had a variety of funding sources, including the ODFA and Ag Experiment Station, and then the CAFO program too, for which we're very grateful. Anyway, if you want to advance. So I have to say so Elsie Weissar is the graduate student that has been working hard on this project for the past 4 or 5 years. She just recently did her master's defense, and the slide set's based on the MS thesis work. And the nice thing, she did a very nice job of summarizing 4 years, 4 seasons of operation of the bioreactor under a variety of different conditions. Next slide. So I'm going to discuss a little bit the technology. We have an experimental unit at the Corvallis Dairy Center. We installed this about 4 years ago. So I'll talk a little bit about the unit installation, then go into some of the results and questions for further research that have come out of these studies. Next slide. Okay, so most people are familiar in the room are familiar with denitrification, but just quickly, it's a process by where nitrate is converted, hopefully, to nitrogen gas as a means of removing nitrate from ground and groundwater systems. I just show the various steps here: nitrate to nitrite to nitric oxide to nitrous oxide to nitrogen. And ideally, your bioreactor set up so its operating conditions get complete conversion of nitrate to nitrogen gas. Next slide. So this is all mediated through microbes. I won't go into this in too great a depth, but basically the wood chips form a food or substrate for the microbes in the system. When you set the system up, the wood chips are naturally inoculated with denitrifying bacteria that exist in the soil. So as the water flows through the system, you get inoculation. And essentially the microbes use the wood sugars to facilitate the denitrification process. So you do need a carbon source. You do need a source of electrons to convert the nitrate to nitrogen gases. Next slide. This is a schematic of a wood chip bioreactor, showing basically as we have at the dairy center, we're hooked up to the tile drainage system. We're treating tile drainage output. Basically, it's about a 4-foot depth. The water comes in. There's a 40-acre field upstream at the dairy center, and it feeds when there's enough rain, sufficient rain, it feeds the system. And next slide. So this is just this isn't our setup, but there's been a lot of work done in the Midwest because in Iowa, especially with the cropping systems, a lot of fertilizer ends up in the waterways, and this is a fairly inexpensive way of addressing those issues before they become an area of concern. And so this just gives an idea of the scale of these systems. Sometimes they're up to a third of a mile long. They can be pretty big. It really just depends on the land that's being drained and so on. Next slide. All right, so a lot of work done in Iowa. The weather system in the Northwest, the weather trends are completely different. It's almost the opposite. In Iowa, you have the very cold winters, the very hot summers, and then most of the moisture occurring as you move through the summer season. In Oregon, milder winters, the summers tend to be drier, and with most of the moisture occurring sort of in the fall, winter, spring. And so one of the key questions that we were one of the key questions that we were trying to address with the systems, how applicable in the Pacific Northwest were these systems, and were there differences in operational parameters that we needed in order to have the system. Okay, so this is a satellite view of the Oregon Dairy Center. Carol's probably pretty familiar with this. So the field, the shaded area is the field upstream of the bioreactor. As you move down the slide, there's actually a road there, and the wood chip bioreactors are located just on this chart to the left of the solar array. You can see the solar array there, and it feeds into Oak Creek at the end of the day. Again, 40-acre field, mild slope, fairly typical soils for the area, and per the CAFO plan, liquid manure is spread seasonally as conditions permit. Next slide. This is our unit. It's a little bit smaller than the unit we showed before, but it's still fairly sizable. This is actually the second bioreactor unit we put in. The ODFA funded a pilot unit that was about 20% the size of this. We learned a lot when we installed that. It's a little bit upstream of where this one is. It's across the road. A great deal of thought went to this in terms of having it as an experimental unit. So this has some additional features that aren't generally present in these systems. For example, the white ports allow you to sample the liquid at different levels within the bioreactor. Understanding that the liquid closer to the surface would actually have higher oxygen. So there's some interesting questions that come into that. USDA does have guidelines for the bioreactor systems that came out of the Iowa work. We follow those guidelines pretty much when we installed the system. 60 feet by 12 feet by about 4 feet deep. I'm in that picture up there, so you kind of gives a sense of up on the upper left. So Elsie built the system. She designed it. It was part of her master's thesis work. For various reasons, a confluence of events that I was actually pretty much not around, and she did the whole thing. I thought it was a very impressive activity for if you met Elsie, you'd understand. She's pretty impressive. But anyway, the cost of $15,000 there is actually materials cost. It's what, so it didn't include labor or anything else. There was 2 days of excavator time included in that $15,000 cost. The wood chips were about $8,000. And then the aggregate drain valving system was that those units are actually about $2,500 each, or at least they were 4 years ago. They're probably more expensive now. And there, it's a lot of the technology associated with building these units is sort of, so the aggregate drain units, you can hook them up to a tile drainage system and control the water table in the field, that kind of thing. So that's where they were originally developed for. Next slide. So this is just a plan view of the bioreactor as it's been installed. Side view. So on the left is those pictures of the control systems and everything else will be on the left of the figure as you look at it. It's just a CAD drawing of the bioreactor unit. Next slide. A lot of data collected as part of this study. Obviously, water quality data looking at nitrogen. Also interested in E. coli. Turns out that the wood chip bioreactors, in some senses, remediate the E. coli. There's a little bit of, it's a little unclear as to what exactly the mechanism is. And that's actually one of the things that Elsie's been looking at. It's absorption to the wood chips, in which case, you may be able to saturate the system and it stops treating the E. coli, or does it actually has some sort of bactericidal effect? These questions are open right now. In addition to the water chemistry parameters, the E. coli did a lot to do looking at the hydraulic characteristics of the system and how varying those hydraulic characteristics changed the treatment profile of the nitrogen that was going in. Next slide. So basically the flow rate through the system, we didn't actually have a flow meter hooked up, but we could, with the hobo, we could get an idea of the head that was in the system. And from that head, we could get an idea of flow rate. Hydraulic resonance time, so that's basically the time that the fluid, an element of the fluid remains in the bioreactor. It's a very important parameter affected by a variety of different operational characteristics of the bioreactor. And we did some, or Elsie did some sodium chloride spike tests, where basically because of the way the system was designed, we could put in a bag of salt and monitor the outlet and figure out about how the internal mechanics of the bioreactor were working. The kinds of things we looked at was
It's not popping up on mine, so I'm not sure.
You should just push it over. Is it on the screen right there? No?
No. I don't know why it's popping. Sorry, everyone. Hold on.
Continue watching.
See it.
You do?
Usually it's on our.
Yeah, because nothing is on my
All right.
computer at all.
So can everybody online still see the slideshow? Let's see what happens in 7 seconds.
Yes.
cut the blue wire.
Right, exactly.
No. Oh.
Almost.
Oh.
There it is.
Okay.
All right. Sorry, y'all. Internal room.
I think.
Gotta go back a little bit.
Down the next slide. Yeah, there we go. And then the other thing that we're looking at is the percent of the inlet that's actually treated. So if you have a very heavy rainfall, the system is actually set up that you to bypass. There's a in the aggregate drain control system, when the water reaches a certain level, it overflows and it goes into a bypass. And the reason to do that is the bioreactor does not work very well if you're oversaturated with water. So a certain percentage is bypassed, and you select the height. You can select the height at which that occurs. There's a gate and slide system in the hydrodrain unit. Next slide. So this is actually 3 seasons. The first season, we weren't too concerned about hydraulic retention time, which is the orange trace you see on the next 2 slides. It's pretty clear that we're doing something with the bioreactor. The orange trace is actually the head in the bioreactor. So what Elsie did, which I thought was quite clever, is she buried the head throughout the season. And what we were doing at each head height, which is basically affects the time that water goes, the velocity of the water through the system, and the time or contact time, and so on with the wood chips. So she did that 2 seasons beyond the first season, where we were just kind of getting an idea of how the bioreactor would work. The other reason for waiting for the second season is it takes a little while for the bioreactor to break in, because you have to get it inoculated and things have to grow up. And so in a sense, the first year, if you're doing scientific studies, the data, it's just not unusable, just because there's so many different things changing in the system.
So is that, so the startup time for obviously for scientific research is really important to get it stable, but
You're getting
in
treatment.
practice,
In
like-
practice, you get treatment in the first year. In fact, the treatment in the first and second year is probably the best it will ever be. It's still, I mean, it's good as things progress, but when the wood chips are fresh and all that sugar's on the surface and everything else, microbes are very active. But the lifetime, if you're assuming you follow the NRCS guidelines, the lifetime is 10 to 15 years. So you would have to change the wood, after 10 to 15 years, the wood chip sugars are consumed, and you'd have to open the system up and replenish the wood chips. Next slide. So some hydraulic parameters. Again, one of the things that we were interested in when we were doing these studies was the effect of different temperature range from the Midwest. So we have average daily temperature. We have the hydraulic retention time as measured by the salt. It's flow rate in cubic feet per second, and then percent treatment anywhere from 7.4 to 92%, depending on the operational parameters of the bioreactor. Next slide. All right, results. How am I doing for time, by the way?
You're doing good. It's only 2.
All right.
So you're just now starting your presentation. So you're good.
I'm good. All right, results onwards. So the blue trace on these charts is actually the outlet, and the purple trace is the inlet. And as you can see, I mean, on the left-hand diagram, it's really pretty obvious, like there's those inlet spikes, and the outlet is basically below the EPA drinking water limit. And again, in the second and the third season, again, similar treatment. A tremendous reduction in that nitrate. So the system has been operating pretty successfully.
Can I ask a question about the field conditions? So those are the fields that are draining. How did you look at like the inputs that were going on the field, and like when you would see a spike, or like how that relationship was? Or were you guys spiking the reactor to see what came out the other side?
No, this is from the field. We have not correlated inputs. The input measurement is what's coming in the pipe into the bioreactor from the field.
Okay.
We haven't actually looked at the records and said, on day 1, this was applied, and then we see an increase in day 3.
Okay.
That would be a very interesting study to do. But we haven't gotten that sophisticated yet. But anyway, 3 seasons and 3 years of good treatment. And the important thing is this is in the Cascadia climate regime. So obviously the technology, and you know, when you think about it, during the summer, the system sits there dry, but it still functions. It's like, I bet if you were to open it up, and we haven't done that, but it would still be damp. So the bacteria in suspended animation. And in the winter when the first rains hit, just fires right up. All right, next slide. Looking at nitrite. So Elsie made all the liquid measurements for the denitrification train. Not very high levels of nitrite, as one would expect, since that's the intermediate and would be consumed almost immediately. So just again shows that the bioreactor is functioning well within the Cascadia regime. Next slide. Also looked at ammonium, which is kind of interesting because obviously it's not very mobile in the soil, but we're seeing some at a much lower level, on the order of 2 to 4 milligrams versus the nitrate, which was higher. So it's not the scale is much smaller with this one. Next slide. So key results, concentration range. So we did see some significant spikes. I should also say that, yeah. So for the first year, it was a little bit it was a little bit odd because the tile drainage system was actually open. I believe they were fixing some blowouts or something like that upstream. And so, in a sense, it fed directly into the bioreactor. There was no soil column. But once the blowouts were fixed, it stabilized. The next parameter, removal rate, is grams of nitrate per day. As you can see, a good removal rate. The second season was, I think, there was some, Elsie could give you chapter and verse, but I think that the second season weather conditions were significantly different, which is one reason why we had the much higher rate of nitrate in. But in terms of removal rate, it was very good. Removal efficiency anywhere from 60 to 80%, and then some other parameters. So removal rate per active bed volume, again, she was varying the height of the liquid in the reactor. So you would only have seen treatment up to the surface of the liquid, basically. And so she also did a calculation looking at removal rate per active bed volume, and then the nitrate load reduction was also good. Next slide.
Are you guys continuing to collect data?
I think that Elsie moved heaven and earth for 4 years to collect this huge data set. And I think that for this year, we decided that she would do some analysis. She's been doing some analysis as she went along, but it's actually a tremendous amount of time and effort to get those samples processed. She had undergraduate help, but she's the ringmaster.
Yeah.
So
I was just wondering on that previous slide, as you saw the removal efficiency in the first year is 80, and it was slowly going down. Just like what that trend over time, because you said it's good for
the first 2 years are the best. The
Yeah.
first 2 years are the best. I mean, and you do see it goes up, and then you do see a sort of, it's not exponential decay,
Sure.
but you do see a decay with respect to time. And the unit's still functional. I mean, we could wait until you do your year 5 and year 10 data gathering regime and take a look at that.
Oh, do you want me to go back?
No, that's fine. So, I mean, one of the things is, this is a very long time constant system. I've been lucky. Elsie has been part-time. She's been here for 8 years, working on various things. She worked in it as an undergraduate, and she's worked in it for a master's. She's working on related things for PhD. So there's been this institutional memory at the graduate student level that has been very helpful. That is not normally the case. All right. Again, just more different parameters looking at various things. Total nitrogen as opposed to just the nitrate. Next slide. Okay, so this is a research unit, so you wouldn't normally see the piping system that you see there. But it's set up to allow you to sample down the length instead of just at the inlet and the outlet, and also at different heights, depending on the hydraulic retention time. And the other key factor here is there's actually plywood baffles in there. So what we were trying to do, so there's a serpentine path for the water through the unit. And the reason for that, if we wanted to reduce the possibility of dead zones and make sure that the entire unit was being used. And that again is not generally the case in these units. They keep it as simple as possible. But anyway, from the inlet to the outlet, there was 6 sampling port setups. Next slide. And so this is actually a longitudinal view of it's a conceptual map of a bioreactor, looking at how concentrations change as you move down the bioreactor. So for example, oxygen is consumed initially and then decreases to about 0, at which point you start to see the denitrification. The nitrite goes up as you move down the bioreactor and then comes down. The nitrate consistently moves down. And then what happens is once all the oxygen is consumed and the nitrogen is consumed, you start to move into a regime where it's possible to produce hydrogen sulfide gas, rotten egg, and then methane too. So the idea is to operate the bioreactor so you're at the optimal stopping point. You don't actually start doing some pollution swapping and producing hydrogen sulfide and methane gas. So, I mean, it's pretty easy to tell when that's happening. You can't smell methane, but the hydrogen sulfide, you can go down to that end of the bioreactor, and with the tubes there, there was definitely a zone of rotten eggs, depending on the hydraulic retention time. Next slide.
And so to manage that, are you just increasing the head for increased flow?
Yeah. You want to flush the system through so that you get a sufficient oxygen at the end of the bioreactor that you avoid the truly anaerobic functionality. And then this is actually the actual internal measurements. And let's see, pH, DO, nitrate. You can see the H2S under the conditions that she was running it. So this is again longitudinal down the bioreactor. So there's the interesting thing about this is we have sort of this conceptual understanding, and then the experimental results pretty much were in alignment with the conceptual understanding, which was nice. All right, next slide. So active management. So you want to make sure that you have that optimum point at the end of the bioreactor. I mean, you can just let the system run. I mean, you don't have to actively manage it. But as an engineer, you just kind of want to play around with it and see if you can improve the point. So you do get better nitrogen removal. That's relative to the full reactor volume. So with active management, so this gets back to the idea of, so when we say 59% of total tile system discharge, you want, this is adjusting the height of the gate in the agri-trains so that you're always just at the tipping point as far as flooding the bioreactor. You don't want to flood the bioreactor, but you want to, operationally, you want to be at that point. And so treat 60% of the tile drainage with active management versus 20% if you just said, I never want to flood the bioreactor, so therefore I'm just going to have this single setting. Larger bioreactors are not necessarily better, again, because if the bioreactor is too long or has too much volume, you end up moving into that pollution swapping phase. So there's actually quite an interesting if a farmer wanted to install one of these systems, there would be quite a rigorous design process that would have to go into making sure that it was sized correctly and function as they would want. It's usually run slower than fast, but you do run into the issue with running it fast. You run into sedimentation issues, and you get too much biomass and it clogs essentially. And then wood chip bioreactor. So we used 1 inch. Basically went down to the bark place and picked the right wood, and then the bark place, which is just, if you want to put bark on the dust in your garden, that was basically what it was. But any wood chip breaks down over time. Hardwoods have more sugars, but they're more expensive. A lot of fir in the Pacific Northwest, that kind of thing, considerations.
You guys didn't look at different wood chip fuel, I guess, and how much removal or activity was for like fir versus hardwood versus whatever.
We didn't, but there are some studies in the literature where people looked at that, and it's something that's intermediate is best between the two for various reasons. But again, the hardwoods tend to be much more expensive than the softwoods, and so let's see. So in the area of pollution swapping, the question would be operationally, are you running in a regime where you're creating methyl mercury? There's some reports in the literature of that. The only reason that we're interested in that is sort of to get the complete picture of what's going on in the bioreactor. Methane production, we'd like to model hydrolysis and transport, and the main reason we want to model it is it'll help with the design process for our producers who are interested. Looking at different alternative designs. So the current design is basically you put a plastic liner in a hole that you dug with an excavator, and you put the plumbing in, and then you close the plastic over the top, put a dirt cap on it, and that's it. The main issue with that is if, at the end of the 10-year period, it makes it a little bit difficult to pull wood chips out and then replenish it. And so something to think about, can you, if there are concrete structures on the farm that could be somehow, either to have a concrete bay, or sometimes there are concrete structures on the farm they might be able to use in the wood chip bioreactor for that. Next slide. So it works in Oregon. I also did a lot of work looking at with backfills, without backfills, the length to width ratio, 3:1 with backfills, 4:1 without. Split flow designs are basically mini bioreactors that you run different. And then further studies needed on potential byproducts. We're also interested in the E. coli remediation. And it would be great to be able to run another season or two of just sample gathering and seeing how that functionality is changing. And then obviously received funding from various sources over the years. ODFA, ODA, our Ag Research Foundation, ARF, and then Luca, Jordan, Rose were graduate students, or undergraduates at Health, and then obviously Elsie. And that's it, I think.
Any questions?
Does anybody have any questions?
I'm not unplugged. See if there's anything in the chat.
Frank, so this is looking at tile lands. Are there other applicable uses that you can think of? I think I heard at one time there was discussions about removing nitrates from groundwater that's flowed through a system like this. Was that something that you guys have looked at or considered?
So I think what you're talking about is like a water polishing system.
Yeah.
So if you have high levels of nitrate coming out from your wells. There's no reason why it couldn't be used for that. In fact, one of the things that Elsie's looking at doing for her PhD is if you have 5 households together, that you have one of these units and that were on a well in an area where there's high nitrate, could you just run the water through a wood chip reactor sort of design? How big would that be? What would that look like?
Yeah.
So sort of water polishing. There are various configurations. For example, if you have a ditch, you can build a unit that just sits in the base of the ditch. So more of a surface water treatment as opposed to tide drainage outlet. There are as many configurations you can conceive of as people are very, what's the term? Creative.
Yeah.
There we are. I mean, at the end of the day, you're just taking advantage of microbes of wood converting nitrate to nitrogen gas. So any configuration allows you to do that.
Any other questions? Transferring now. Well, thanks. Really appreciate it.
Thank you.
Yeah, it's very fascinating research. That we were able to help support it. Who wants to install one now?
Well, okay, maybe I do have a question. Sorry.
Yeah, no, go for it.
Practically, what does implementation look like? Would it just be customized to each farmer's needs and different landscape factors, or what do you?
I would say that for the first, you do have to take into consideration landscape factors and the amount of field that's being drained and things like that. So it's, I would say semi-custom. I would say the first few units that, if one were to get into business of doing it would be custom. And then ultimately, when you put a few in, you'd start to have certain economies of, you'd have a better understanding of how best to address the producer needs. This is a research unit, so it's a little bit more sophisticated than what would necessarily be. But you do have to take into consideration, how much land's being drained, the rainfall patterns, the soil type.
Frank, can I ask you just totally off the wall question? Could you make this go faster if you added a cure accelerator to the bioreactor like we do when we're curing meat? Because we start with either nitrate or nitrite and convert it to nitrous oxide and fix it with a cure accelerator, such as erythrobate or ascorbic acid.
So
Totally off the wall because of my.
That's a great question.
I don't see why not, but I think how much complexity would that add to the systems? Since right now, I mean, I don't know. Right now, the selling point is it's a very simple thing. If a farm has a backhoe, I was willing, and it was $15,000 material, but a big chunk of that went to the bark place. If you have fir trees on your property that you could chip, that would work just as well and be a lot cheaper. And again, if you got into this in a big way, if you had a big unit, those costs would go down. But so again, the major selling point is the simplicity. I think what you suggest would increase the treatment rate, but
Well, that stuff's all crystalline, so you could put it in with the chips, and as the water flows through, it would.
So how quickly would it be consumed would be the question.
Yeah, I don't know.
But
You can do something in a beaker. I got some stuff on campus.
Does it last 15 years, or do you have to somehow?
I don't know. We do it for every batch. I don't know.
So it looks like we have Tammy raising her hand, so I believe she has a question. It would be Tammy S. I don't see the Starks.
Hi, it seems to me that this system is comparable to an above the ground gray water system. Is there a correlation to be drawn there to maybe replacing that wet plant substrate with a wood chip solution that could be built above ground to like accommodate home gardening application?
So I think all you need is a substrate. So yes, I think all you need is a substrate that that provides a sugar source for the microbes. So it sounds like what you're talking about, it's not wood chips, it's some other plant material that provides a substrate for the microbes to do their thing. I guess if it was soft plant material, the nice thing about the wood chips is, again, the lifespan. The soft plant material, you'd probably have to replenish that fairly often.
Yeah, my question, I guess, is would the wood chips be preferable to another type of substrate for that application? Like alternatively, instead of digging down for a ground system, doing it for like a above ground home gardening gray water catchment, basically, is what my.
Yeah, I don't see why. I think what you described would be a viable alternative, but you'd have to do an alternatives analysis in order, again, as an engineer, you'd have to do an alternatives analysis to figure out which one was better in a given situation. So I guess I can't answer your question off the top of my head, but it sounds like what you're proposing would be workable in terms of the above ground system relative to the low down system. It'd also be maybe a bit cheaper and a bit more flexible if it was above ground. So.
Well, yeah, that's, I guess, if the substrate replacement is better with the wood chips, that's very interesting to me for that kind of application. Because
Right.
you know, with all of the different applications that I put into my garden, I'm concerned, you know, like I think about that runoff just in a small scale, you know, so that would be.
So worm beds. So there's a farm, I think it's Royal Farms in Washington, that has worm beds, but essentially it's for treatment of nitrogen, but it's worm beds above a wood chip field. So they not only do they get worms that they can spread on their field from the cow waste, they do get the nitrogen treatment too from the wood chip bed, and that's above ground. So it makes it a lot easier to replenish the wood chips. Essentially, they have 5 acres of worm beds. That's a pretty interesting system.
They spoke to this group about 2 years
Did
ago
they?
in that project.
Oh, okay, very cool.
That's very interesting. Okay, thank you.
Anyone else?
So in terms of ongoing research, it sounds like Elsie has completed her master's degree. Are they continuing on through the PhD work, or are you gonna bring on new?
So she needs 3 publications, and one of them will probably be focused on the virus. We're still going back and forth a little bit. Some of it's dependent on where the funding falls. But we would love to do it, say a 5-year time point on the bioreactor. It was 2019 it went in. So the 5-6 year time point, you could then fit a model and figure out how long you're actually going to get from the wood chips. Really interested in the whole treatment of E. coli by the wood chips. And that just in terms of the bioreactor, other things that we've looked at with sort of the same reactor configuration as phosphate remediation from runoff. So these are all things that we've discussed. You know, at the end of the day, OSU requires that she have 3 first order publications in order to get the PhD. So that's a big constraint on the kinds of things that she can do.
Well, she sounds amazing. And just seems like there's so much potential to come out of this work. So fascinating.
Okay. Well, thank you very much, Frank. I appreciate it. You're happy to hang out the whole time. You gotta rush. We're gonna go to partner agency updates. We can start in the room and then we'll go to folks online. So since DEQ is in the room, do you have any updates for the CAFO Advisory Committee? Maybe it would be really nice, I mean, I know you introduced yourself, but talk to them a little bit about your role, that it's a new position within DEQ and kind of what that looks like and the scope and scale.
Yeah, totally. That feels like the biggest update, just that I exist. I have been in this role as DEQ's CAFO program specialist for about 5 weeks, so I'm still very new. And ultimately, my primary responsibility is really to coordinate and collaborate with fine ODA folks on all things related to CAFOs and to really support their rulemaking and permitting processes and support our farmers in the process of finding the most feasible and safest and most responsible ways to operate. So still kind of figuring out what that looks like in practice, but I'm here to build context and gather information and just meeting folks and getting a sense of where everyone is at with all this so that I can step in and support that process going forward. So you'll probably be seeing my face a bit more and hopefully I'll be meeting more of you in person going forward. It's kind of where I'm at.
Right. Do you have any asks of like the members of this group? Like, I know like we have talked and like you want to go out with some of our staff, but anyone else that may be like a member of the CAC and things that you're interested in that might be helpful for them to know too, is you kind of get your feet under you in your new position?
Totally. That's a great question. I think just broadly, since I am so new, it's really important to me to gain a deep understanding of what's important to you all and what you see as what's important on the ground and how that translates to the policies and the rules and the permits and all of that. So I think if there was anything you wanted me to know as a person in this role, or anyone you think that it would be good for me to talk to in terms of gathering big picture and diverse and holistic perspectives, I'm very open to that. So feel free to get in contact with me. I'm excited to go out on some inspections and just like get my eyeballs on what the scale and scope is of the CAFOs in the state of Oregon. So yeah, if there are any pertinent issues or people or farms or anything that you think would be helpful for me to have a really strong grasp of, I am very open to it and eager to gain exposure to everything related to CAFOs and water quality and so much more that is relevant to that. So feel free to send anything my way.
Any questions for Taylor?
It looks like there's some people are wanting your contact info, so that's just something to be sharing that.
Okay.
If that's okay.
Yes, I have not connected to my computer, so feel free to share my contact info, folks.
Okay. Do we have anyone on from EPA? I didn't see.
We do have a hand
Oh,
raised
yeah, Tammy.
for Tammy Kerr.
Yes, I was just curious to know who Taylor replaced at DEQ. Who was the
Good
previous?
question. I did not actually replace anyone. This is a brand new position that came down through the SB 85 process that was instigated last summer. Likewise, there are some new roles happening at ODA. So the charge is for DEQ to kind of create a more robust CAFO program that can work very closely with the ODA program. So this is a totally new position. And because of that, I think there is some opportunities for us to get creative in what it looks like and what is most beneficial for all the folks across agencies and through different organizations and, working on the farms on the ground to help kind of determine what's most helpful. So.
Yeah, Tammy, it's a good question because like Taylor said, we got two positions through Senate Bill 85. One's a CAFO inspector, which once we get the manager on will be a position we'll hire. And then the other one is permits coordinator, person who will do like the writing of all of our permits, permit updates, individual permits like that. That'll be their focus. part of SB 85 called out a requirement for new and large expanding to have consultation meetings with multiple agencies before they submit an application to register to a permit. And so I think that was the primary impetus why the legislature said, oh, we've just given DEQ a new body of work to come do those consultation meetings. And so we're going to give them a dedicated CAFO permit related person within their agency that'll be that conduit or coordination between ODA and DEQ as we do this CAFO work. So that's kind of how it all fits together, if I'm recalling everything correctly.
Yeah, thank you for that context. And I am housed within the water quality division alongside the permit folks at DEQ. But I'm also aware that, CAFO related questions and topics transcend just water quality as well. So I envision part of my role being just a communicator and a connector with all the different folks and programs that are related to this work.
Thank you very much.
Any other questions? Is there anyone from EPA on? I know Nick said he couldn't come, but he was going to share the invite with a colleague, so. Okay. What about, well, we do have Amy with NRCS. Amy, do you have any updates for us?
No, I'm sorry, I don't. I honestly was not even certain what this meeting was about. This is my first foray into the existence of such a group. So I'm, like I said, bit of a fly on the wall to see what is existing out there. I came from Utah, which is well regulated, but different scenarios. We're a little short on water compared to you all. And so it's neat to see the new technologies and stuff. So thank you. I appreciate you letting me sit in.
Sure, absolutely. Anybody from USDA? Anyone else have an update for the group that they want to share? Tough crowd. Okay, maybe we have some public comment. Does anybody want to do public comment? If there is, please put your name in the chat and then we'll call on you. Or just raise your hand if you're on the screen. That works too.
Brian, I'm so sorry if I mispronounced this, but Postwitz?
Oh, yeah. Hi, that's pretty
Hi,
good.
Brian.
Brian Posowitz. Yeah. Hi, everybody. Brian Posowitz with Water Watch of Oregon and Humane Voters Oregon. This is really more of a question, and apologies, I was on about 10 minutes late. I was stuck on a phone call, so this would have been more appropriate earlier. But first of all, Taylor, welcome aboard at DEQ. Glad to hear you're in that position, and that there is that position, and look forward to working with you some. And then I wanted to ask, I know you covered this early in the agenda, but I forget exactly what you're calling it, the remedial action plan at the Canyon Farm site. I think I've seen in some places, I don't recall whether it's media accounts or somewhere else, that the as I think everybody knows, that's the site of the former Lost Valley Farm and at one time the proposed Easter Day Dairy. And there were a bunch of dairy barns on the site and some waste processing facilities, including the waste ponds. I think I've seen some things that said that's been dismantled, and I wanted to see if that was in fact the case, or confirm if that's in fact the case, and if so, has ODA actually been out there and seen that and inspected that and documented that in some way?
Yeah, thanks for the question, Brian. So yes, that's the site we're talking about with those remedial actions. the site has been fully decommissioned. So going back in time, when it was originally the Lost Valley site, and that went through the bankruptcy, the agency required a full cleanup of the site, like removing all animals and all animal waste. So all the lagoons, and at that time, all the lagoons, everything was cleaned up and removed and stabilized at that point. So no additional animals, no additional animal waste, all clean, including the lagoons. And so that sat with no animals until recently, when the site was then further decommissioned. So the infrastructure for it to operate as a dairy was all removed. So within the barns are still there, but like the stanchions for the cattle are gone, the milking parlor is gone, the tanks are gone. Any of the lines that would have gone from the lagoons to land application sites cut and capped. And we did a full inspection to confirm that when we canceled and decommissioned the permit. So the permit has been canceled. It's no longer a permitted CAFO site, and it's been fully decommissioned.
Okay, great. Yeah, thanks for that info. And then it sounds like there is some ODA documentation of sort of that site visit and inspection.
Yes.
Yeah. Okay, yeah, thank you for answering my questions.
Yep. Anyone else? No. Are there any general industry updates? Tammy Kerr, Tammy Denny, any updates? Cool things going on, bad things going on? A lot going on with fires on the east side of our state, which is impacting cattle producers and ranchers.
I can share that we are serving as a connecting point between the governor's office, the state and federal agencies for information out to our ranchers and encouraging our ranchers to make contact with, excuse me, local NRCS and FSA field offices to document any losses. In the meantime, while we wait for these federal programs to kick in, which takes some time. So that's where we are currently, but we are going to serve as that linkage to the best of our ability and pushing out fire updates as well. So that's what we know at this point in time.
Thanks, Tammy. Yeah, just to add to that, so ODA is the agency responsible for ESF 11, which is animals and animal health for emergency response. So we have a group of people headed by our state vet that is meeting on a daily basis, doing briefings about what we're hearing or any requests the agency is receiving for help through the OEM's system. So far, I don't believe we have any direct requests, but we are, like Tammy said, also coordinating with people on the ground and with the governor's office and OEM on any needs that producers out there need around that. I know Hillary Collingsworth, who has a lot of those permitted facilities on that side of our state, has been in touch with all of them to see how they are doing and what their needs are. So it's something that we are watching very, very closely. Our role also expands to pets and like those other things too. So like that's also what our emergency response folks are looking at for sheltering of all types of animals. But yeah, it's a big concern out there. Tammy Kerr, anything on the dairy side of things? Maybe she stepped away. Okay, if there's nothing else, that's the agenda for today and we can adjourn. What, you have something? Oh. All right, thanks everyone for joining and we will see you all next time.
Tammy did unmute.
Oh, did she?
No.
Tammy, did you go? No, you're good? Okay.
Sorry about that.
All right, thanks everyone, appreciate it.
Thanks.
That's just laughing, because that's 15 minutes late.
Yeah.
I'm the department head. So somehow that person is sit on it.
We appreciate you.
But I'm a meat scientist, so I don't know this stuff. Curing, I know about curing meat.
Yes.
It's the same reaction.
Is the meat sciences facility, is it a permitted state inspection?
It is a federal inspector.
Oh, it's federal,
facility,
that's
but
right.
it is permit. I mean, it does
Yeah.
have all the other
I don't
stuff.
know if you guys are part of the state one.
No,
you're
she's been
feds.
trying to get us to do it,
But you're already fed, so why do you
yeah,
say?
well, we're only feds on the slaughter side, so we gotta get it on the processing side because with the Beaver Classic brand, they do want to ship across state lines and you can kind of do it by saying we're retail exempt. You can get away with that if your department head's not a meat scientist. But their department head's a meat scientist,
So-
like, we're not getting away with
Yeah.
it. But my